Hi everyone. The velocity of a particle traveling in a straight line is given by v of t equals 50 minus te to the negative 1/2 t meters per second. T must be positive and t is in seconds. So the first thing we're going to do is state the initial velocity. So that just means when v of the t would be 0. This would be when t equals 3. So we do v of 0 and take your formula and plug in 0. So you have 50 minus 10 e to the negative 1/2 times 0. So this equals 0. Anything to the 0 power is 1. So what you're going to get is 50 minus 10, which equals 40 meters per second. And then do the same thing for 3. So you get 50 minus 10 e. When you plug in 3, that's going to be negative 3/2. And putting that in the calculator gives you, write it in 3 significant figures, 47.8 meters per second. All right. Now it states, how long will it take the particle's velocity to increase to 45 meters per second? So you're merely just going to set 45 equal to 50 minus 10 e to negative 1/2 t. And subtract 50 from both sides. Negative 5 equals negative 10 e to the negative 1/2 t. Divide both sides by negative 10. So you get 1/2 equals e to negative 1/2 t. And take your natural log of both sides. So you get ln of 1/2 equals negative 1/2 of t. And so therefore t equals ln of 1/2 divided by negative 1/2. And that gives you approximately 1.38629. We need to round to 3 significant figures. So it's going to be count 3. 6 is bigger than 5, so round that up. So our final answer would be 1.38 seconds is how long it will take to increase. That would be your t. All right. Discuss what happens to the velocity as t increases. So basically, as your t gets bigger and bigger, so you just kind of take the limit as t gets bigger and bigger, that just gets bigger and bigger as well. So this is going to go to infinity as well. This number just gets larger and larger. So you can plug in some numbers here. We already know when we plugged in 0, we got, what did we get? When we plugged in 0, we got 40. And when we plugged in 40, we plugged in 3, we got 47.8. And we have to start where t is 0 or bigger. So there's that. Show that the particle's acceleration is always positive. Well, what we can do is you kind of do a little graph here. If you graph this one, well, let's graph the antiderivative of this. So let's graph s of t. When you graph that, you're going to get 50t plus 20e to the negative 1/2 t. And then when I got my constant, that was plus 20. And you put that in the calculator, you're going to get something like, we know at 0, this goes through 40. So let's put 40. You get a graph that's coming through, let's see, 1, 2, 3, 4, something like this. So remember, below the t-axis, it means it's negative. Above the axis, it is positive. So from here, it's always accelerating for this. Now, if you graph the other one, so let me go and do that real quick. Let's do the zoom thing here. That one, if you just graph that, let's zoom standard. Let's just do that, see what happens. No. We can plug in some of our values. So you have 0. That's going to go to 40. So let's call that 40. And then we had a time 3. That was at 47 point something. And you can plug in some more, and it's just going to go like this. So it's going to keep going, get increasingly larger and larger. All right. So the acceleration is positive if it's above the t-axis. And it's also pretty much given here. The last one is find the total distance traveled by the particle in the first 3 seconds of motion. So we're going to take for our total distance is going to be s of t equals the integral of v of t dt. Now, so what you're going to do is our integral is going to be 50 minus 10e to the negative 1/2 t. And we want to evaluate this from 0 to 3. So when you take the antiderivative of this, it's going to be 50t. And then for this, you're just going to multiply this by 2. So negative 2, so that's going to be plus 20e to negative 1/2 t. All right, and then you have your plus c. But we want to evaluate this from 0 to 3 over that interval. So you merely plug that in and find the total distance. Now, we don't have to worry about a sign diagram. We already know from our graph that this is constantly going up. So we don't have to worry about whether we're subtracting or adding. We're going to be adding the two integrals. So this is going to be 50 times 3 plus 20 e to negative 3/2. And then you're going to add, because we're adding our distance here. You plug in your 0, you're just going to get plus 20. So when you plug that in your calculator, you're going to get 150 plus 20 times e to the negative 3/2. So you can type in negative 1.5 and then plus 20. And that gives you 174.4626. We want to round to 3 significant figures, so there it is. Since if you're using the rounding, this 6 would round this up to 5, and 5 rounds that up. So your total distance is approximately 175 meters. And that's it. Thank you. Have a nice day. Bye-bye.